In this lesson, we will take a look at a review of basic trigonometry. And before we do that, I'd like to back up a little bit and actually take a look at something from geometry. So I'm going to go. So here we have two triangles, and they're both right triangles. So one of the angles is 90 degrees in both of those, as you can see from the picture. And they also have another angle that is the same. Let's say this side is 40 degrees. This angle rather, and in the big triangle that angle on the left hand side is also 40 degrees, and that of course tells us that the third angle must be the same because the sum of the angles must be adding up to 180 degrees. So the top one should be 50 degrees on this one and 50 degrees on this one. So what we have here is three of the angles are exactly the same, and we have basically two similar triangles. And there are certain ratios that we can set up in similar triangles. So for example, the ratio of B to A in a small triangle will be equal to the ratio of capital B to capital A in the large triangle. And there can be, we can set up all sorts of ratios like that, or 6 of them to be specific. But let me begin with that one. So what we're saying is the ratio of B to A in the small triangle equals the ratio of capital B to capital A in the large triangle. And we can also say that the ratio of A to C in the small one equals the ratio of A to C, or capital A to capital C, in the large triangle. And also the ratio of B to C in the small one equals the ratio of B to C in the large one. And because these ratios come up so often, mathematicians decided to give special names to these. So in that regard, if you just consider this angle to be our angle theta, so we have the same angle over here. So when we have B over A, mathematicians, they call this opposite over adjacent. So the opposite side of the 40 degrees to the adjacent side of the 40 degrees. So that's your opposite over adjacent ratio. And they give it a special name, tangent of that angle. And when you have A over C, that's considered to be your adjacent over this part that we call the hypotenuse, right? And that's the longest side, that's the side across from the 90-degree angle. And that ratio is called cosine of the angle theta. And the third one, B over C, is your opposite over hypotenuse. And that one is referred to as the sine of theta, or is defined as a sine function. And the nice thing about these trig functions is that mathematicians have determined the values of these trig functions for practically any angle. So if they recognize that there is a right triangle with a specific angle, let's say 47 degrees, and if they happen to know one of the sides of this triangle, let's say that they happen to know this side is 100 feet. They can actually determine all the other sides because they know what the ratios should be in a triangle, in a right triangle with 47 degrees. So for example, if they're trying to determine this side x, what they can do is simply write down the appropriate ratio. Like in this case, we want to relate 100 to x. That's opposite over adjacent. And which trig function is that opposite over adjacent? That would be the tangent function. So we can write tangent of 47 degrees equals 100 over x. And from there, we can get tangent of 47 degrees from the calculator. And let's multiply both sides by x. X times tangent of 47 degrees equals 100. Therefore, x equals 100 over tangent of 47 degrees. And if we get that on the calculator, again, make sure you're in degree mode. So I'm just going to enter 100 over tangent of 47, and I'm getting 93.25. And the units, of course, would be feet. So the unknown side is about 93 feet long. So once again, knowing the trig function values is extremely helpful, because then if we can recognize that we have a right triangle, and as long as you know just the one of the angles besides the right angle, then basically you can solve the entire triangle. Of course, you also have to know one side, a right triangle, and with one extra angle, then you can determine the other two unknown sides. So that's really helpful tool to solve triangles. And then there's, of course, so many other things you can do, as some of those we're going to be using in calculus as well. In trigonometry, you have, first of all, you define those 6 basic ratios that you can create in a triangle. And these are defined as sine, cosine, tangent, cosecant, secant, and cotangent. Now, I hope that you guys remember those ratios. Again, this session is not meant to be for someone who's never ever seen trigonometry. So I hope you've seen it before. So I hope you can actually jot down the values for those. And I'll remind everyone this little trick. So SOHCAHTOA. This tells you which trig function represents. For example, sine represents opposite over hypotenuse. Cosine represents adjacent over hypotenuse. Tangent represents opposite over adjacent. So again, here we have our basic right triangle. If we're dealing with the angle theta, the side that is one of the legs and that is adjacent to theta is called our adjacent side. The side that is directly across from theta is our opposite side, and the longest side, or the side across from the right triangle or the right angle, is your hypotenuse, right? So I hope you can remember those. And right now I'm going to reveal the values. So sine, which I've already mentioned, is opposite over hypotenuse. Cosine, so for this triangle that would be b over c. Cosine is your adjacent over hypotenuse. In this case, it's a over c. Tangent is your opposite over adjacent, so that's b over a. And you have the reciprocal functions. Cosecant is reciprocal of sine, so hypotenuse over opposite. Secant is reciprocal of cosine. Cotangent is reciprocal of tangent. So these are the 6 trig functions that we define. And then in trigonometry, you go on to define those not just for right triangles, but for any angles using the unit circle. And let's also make sure that we remember how to write cotangent in terms of tangent. I'm sorry, cotangent in terms of tangent, of course, is 1 over tangent, but cotangent in terms of sines and cosines is cotangent is cosine over sine. Tangent is sine over cosine. And in terms of sines and cosines, what is secant going to be? 1 over cosine, right? And cosecant is 1 over sine. Again, if you don't remember any of these things, I would highly recommend use flashcards. You know, you need to get up to speed with your calculus class. So this is the time to get through that material, to memorize these basic identities, which we're going to be using throughout the semester. And then a few more basic identities you might have seen in calculus. Sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. As a matter of fact, the last two identities can be derived from the first one. If you just divide both sides by sine squared, you're going to get one of them. If you divide both sides by cosine squared, you're going to get the other one. And a couple more identities that would be helpful to remember. Sine of 2 theta is 2 sine theta times cosine theta, and cosine 2 theta equals cosine square theta minus sine square theta. You do not need to memorize this last line, although it would be helpful to be familiar with those, but definitely everything above this line you should be familiar with and you should memorize. Okay, then I'd like for you to be familiar with certain angles, special angles or trig functions at special angles, such as 30, 45, and 60 degrees, as well as around the unit circle at 0, 90, 180, 270, and 360 degrees. And of course, you should also be familiar with converting angles from degrees to radians and so forth. And let me just remind everybody that pi radians equals 180 degrees. So if you ever need to convert, what about 30 degrees? How many radians is that? And the easiest way to determine that is to recognize that 30 degrees is 1/6 of 180. So since 180 is pi radians, then 30 will be 1/6 of pi. In other words, pi over 6 radians. Another way to get that would have been you just take the degree measure and you multiply it by pi over 180, and that will also give you pi over 6 radians. So for example, 60 degree would correspond to, again, multiplied by pi over 180. 60 goes into 183 times, so you have pi over 3 radians. Again, so degrees and radians are two different units, two different measures or ways to measure angles, and you should be able to know in this class how to go back and forth between one and the other, from degrees to radians, radians to degrees, and so forth. Right now, let's stick with degrees, and let's remember what are the important, for example, the sine function at 45 degrees, 30 degrees, and 60 degrees. And I would like for you to pause the video right now. If you could, fill in all the blanks here. Again, this is something I expect you to know from trigonometry, and please come back and take a look at the answers. At the moment, I provided you with these triangles. I'm not going to provide you with those on any test. You could recreate those, but I really think, knowing trig functions at these special angles is something you're going to use all the time in calculus and beyond. So I would suggest not even creating these triangles in order to get the sine cosine values. I would suggest this is something you need to memorize. So if you haven't already done so, this is the perfect time to do that right before at the beginning of this calculus class. Okay, so sine 45 is 1 over the square root of 2. Again, we can see this opposite over hypotenuse. Cosine 45 is the same. Adjacent over hypotenuse is also 1 over root 2. And 1 over root 2, if you get rationalize the denominator, it turns out to be root 2 over 2. And tangent is the ratio of sine over cosine, right? So the ratio in this case is just 1. Tangent 45 is 1. And 45 degrees can be also represented as pi over 4 radians. So tangent of pi over 4 radians equals to 1. Okay, sine of 30 degrees. Again, you could take a look at here. If this is your 30 degrees, it's opposite over hypotenuse. For that, sine will be opposite over hypotenuse, so it'll be 1/2. And what about cosine 30 degrees? Cosine will be adjacent over hypotenuse, that's root 3 over 2. And tangent will be the ratio of this to that. So if you literally take the ratio, you will end up with 1 over root 3, or that's in simplified form, root 3 over 3. It's okay with me if you leave it at 1 over root 3, that would be fine as well. So what I would suggest is, for sure, know your values for sine and cosine, and you can always get tangent from that if necessary. Okay, what about sine of 60 degrees? So for this triangle, this is our angle. Sine is opposite over hypotenuse, so root 3 over 2. Cosine will be 1/2. Tangent is their ratio. That turns out to be radical 3. Now, notice something. Sine of 30 degrees is the same as cosine 60, right? And also sine 60 is the same as cosine 30. As a matter of fact, anytime those two angles add up to 90, like sine of x and cosine of y will be the same as long as x plus y is 90 degrees. And you can see that clearly here, sine 45 degrees equals cosine 45 degrees. So what I would suggest is just remember that sine of 45 is root 2 over 2, and that will be the same as cosine 45. Okay. Then if you just remember, sine of 30 is 1/2. From that you can get cosine of 60, which is also 1/2, right? And then cosine of 30, basically that would be the remaining value, because there's basically three values here, root 2 over 2, 1/2, and root 3 over 2. And if you know sine of 30 was 1/2, basically cosine of 30 will be the other value, root 3 over 2. And that will be the same as sine of 60 degrees. Again, all I remember is this one, and that there is another value such as root 3 over 2, rather. And we can easily get the other ones from that. Sine 30 is 1/2. That means cosine 60 will be 1/2. So sine 60 must be the other value, root 3 over 2. That means cosine 30 will be that same value, root 3 over 2. So cover everything. If you haven't yet memorized this, please take a moment to do that. And also a few more important angles. And now we're going to take a look at the unit circle. For example, what happens cosine at 0 degrees right here? And let's just say for any triangle on where the vertex is on the unit circle, the x-coordinate is your x, the y is y, the hypotenuse is the radius of the circle, and if the radius is 1, so when you have, let's say, the sine of that angle theta, you have sine theta equals y over r, cosine theta equals adjacent over hypotenuse, so x over r. But when r is 1, you have sine theta equals to y and cosine theta equals to x. So along the unit circle, you just have to remember that sine is always going to be the same as the y-coordinate, and cosine will be the same as the x-coordinate. So for instance, at 0 degrees, if you just write the coordinates at 0 degrees, right there you have the x-coordinate is 1, y-coordinate is 0. So cosine will always be the x-coordinate. And I'm going to get a clean sheet of paper here. So at any given point, what you have here is x comma y, which is the same thing on the unit circle as if you define this angle as your theta, you have cosine theta comma sine theta. So when you look at any value, like such as right here, this is your 90 degrees, also known as pi over 2. So what will be the cosine there and what will be the sine? All we have to do is write the coordinates at that point, x comma y. There x is 0 at that point, y is 1. So automatically we know cosine of 90 degrees is equal to 0. Sine of 90 degrees is equal to 1. So similarly, you can get all the other ones around the unit circle. So cosine of 0 is, we already did the pi over 2, or 90 degrees. Cosine is 0, sine is 1. At the 0, 0 point, rather at 0 degrees, which would be your point right here, the coordinates there are x is 1, y is 0, right? So that means your cosine of 0 degrees will be 1, because basically the angle there, the theta is basically 0, so your cosine of 0 is 1, and sine of 0 is equal to 0. What about over here at pi radians, or 180 degrees? So let's write the coordinates. The x-coordinate is -1, it's the unit circle, right? So the lengths are of just 1 unit plus or minus. So the y-coordinate there is 0. So what can we say about cosine of pi? If you said -1, you were correct. And sine of pi, that would be 0. And what about over here? at 3 pi over 2. Cosine of 3 pi over 2. Again, the coordinates there are your x is 0, your y is -1, so cosine there is 0, and sine at 3 pi over 2 is -1. So let's check those values. So it's 0, cosine is 1, sine is 0. At pi, cosine is -1, sine is 0. At 3 pi over 2, cosine is 0, and sine is -1. So those are other important values you should be familiar with, and you should definitely know those. And we can use now things that we've learned so far to solve some triangles. So definitely be familiar with solving triangles, given one angle, one side, and so forth. So I'd like to give you a few moments to solve these 3 triangles. Please jot down each one, work on it, and come back to check your answer. Okay, for the first question, let's think about which trig function would be the best one to use if we're going to solve for x. What we know here is that one angle is 30 degrees. We have information about the hypotenuse, and we're trying to find right now the opposite side of 30 degrees. So which trig function relates opposite to hypotenuse? So that, of course, is sine, right? So it would be helpful to write sine 30 degrees equals x over 5. And from there, since we know what sine 30 degrees is, we can easily solve for x. And sine 30 is 1/2. We have memorized that, right? And from there, we can multiply both sides by 5, and we can solve for x. X equals 5/2. Now, of course, you could have also used a calculator. You have sine function on your calculators. However, for these basic angles, I really want you to know the values by heart. And sometimes I'm going to ask you to give me the answers in exact form, such as √3 over 2 and so forth. But if you are going to use a calculator for some other angles like 53 degrees and so forth, of course, you're not going to memorize everything. You're going to use the calculator. Just make sure that if you're given degrees, make sure that in your calculator you select the correct mode, the degree mode. And if you're ever given something in radians, make sure that you're in radian mode. So that's the only thing to pay attention to when you're using a calculator with trig functions. Okay, what about the next one? Next one, the unknown is the angle. And for that one, which trig function would relate the opposite to adjacent side? If you say tangent theta, you are correct. So we write tangent theta is 4/3, and there to get theta, we need to apply the inverse tangent to both sides. So here you could certainly use a calculator and just do a second tangent in parentheses 4/3, and you will have, if your calculator is in degrees mode, you will have 53 degrees. And the last one, you have two sides, a right triangle, you're trying to determine the third side. There you don't even need the trig functions, right? Because good old Pythagorean theorem will come to the rescue. So we can just say 2 squared plus 4 squared equals x squared. From there, x squared is 16 plus 4 or 20. Take a square root, and we get square root of 20 or 2√5. And here are a few more examples. Please take a moment to solve these, and we'll go over the solutions momentarily. And it looks like this question is quite similar to the last one, just a slight twist to it. So now we're solving for the hypotenuse h. And from the last question, you may already know the answer, but let's go through the motions. So for this question, once again, to get h, you would start with the sine function. So sine of 30 degrees is equal to opposite over hypotenuse. And we know this is 1/2 equals 5 over h. To solve for h, cross multiply both, so you get h is equal to 10. And over here, we're going to solve for the adjacent side of 30 degrees. And we're given that the opposite side is 5. So which trig function would you use if you know the angle, the opposite side, and you're trying to solve for the adjacent side? tangent would be perfect, right? So tangent of 30 degrees equals opposite over adjacent. And what do we know about tangent 30 degrees? It's sine 30 over cosine 30. And if you write those down, you're going to get 1 over radical 3 equals 5 over x. And multiply both sides by root 3, and you will have x equals 5 times the square root of 3. Next, we will take a look at a few identities. As a matter of fact, before the identities, let's kind of get warmed up a little bit. Let's simplify this quantity. And the way we're going to do is, we're going to multiply sine and distribute the sine here and distribute the cosine here. So if we do that, we have sine times sine, which is sine squared theta. Then we have sine times cosine, plus, now distribute the cosine. You have cosine times cosine, which is cosine squared theta, plus cosine times sine. And all we need to do now is simplify this a bit. So this is where knowing those identities is very helpful. For example, sine squared plus cosine squared, we had seen that earlier, right? That's 1. And sine cosine plus sine cosine, that's really 2 sine cosines. And there's an identity for that one also, and that one is sine double angle identity. So you can leave the answers like this, but I will also accept this one would be fine as well. And here are a couple more simplification problems involving trigonometric functions. The first one is 1 minus sine squared theta over 1 plus sine theta. How could we simplify this? So as you can see, even though it's a problem from trig, it really relies on algebra, factoring that is. So on the top I see difference of two squares, 1 minus sine squared, and we can write that as 1 minus sine times 1 plus sine, and the bottom is 1 plus sine. And we can cancel the 1 plus sine factor from the top with the 1 plus sine on the bottom. So here we have 1 minus sine theta as our answer. And what about the next one? Simplify cosine theta times tangent theta times cosecant theta. Again, it helps to maybe try a variety of things. It helps to know the trig identities, to be honest with you, because then you can try different things. For example, here have tangents and cotangents. You can try to write all of them in terms of tangents. In this case, you have a cosine, a tangent, a cosecant. So it might be a good idea to write everything in terms of sines and cosines. So here we have cosine theta. Tangent can be written as sine over cosine. And does anybody remember cosecant? That was 1 over sine theta, right? And now we can cancel. Again, because this is a multiplication, we can think of it as an entire line, the long line here. Everything here on the top is the numerator, everything multiplied on the bottom is your entire denominator, so we can cancel things from the top and the bottom. And look at that, nothing is left behind. We're left with just a 1. So our answer there is going to be just 1. And I would also like to look at, even though this is not a trigonometric example, some exponents, problems from exponents, because very early on, I would say about our third or fourth lesson, you're going to have to remember your basic exponents with negatives and radicals. So for example, x to the negative 3, how would you rewrite that? Anytime you have a negative exponent, write it as a reciprocal with the positive exponent. So that will be simply 1 over x to the third. So the general rule is x to the negative m is 1 over x to the m. How about x to the 1/3? In that case, you have a fractional power. So that is telling us the third root of x to the first. In other words, third root of x. And there the rule is x to the m over n. the denominator is your root, so it's nth root of x to the m. Okay, here you have a combination, a negative and a fractional. I would first get rid of the negative exponent, which is 1 over x to the 1/2, and then get rid of the fractional exponent, write it as the square root of x in the denominator. Okay, simplify x to the 1/4. Again, that would be 4th root of x to the first, or just 4th root of x. And finally, simplify x to the -4th. Based on the rule we have just seen or reviewed, that will be 1 over x to the 4th. Typically in this class, when you leave your final answer, I will always ask you to leave it with positive exponents. So those are some review of the properties. And this is a little bit of a trick question. Simplify x squared plus y squared all over x squared. Well, I see this so many times that students, I guess it's very tempting to cancel the x squares, but just a big reminder that we cannot simplify this. You cannot remove the x squares because you have a plus sign. Had it been a product up there, certainly you can simplify the x squares there, right? But with an addition, you have terms, not factors, and that you cannot simplify. And here I have an example from exponentials and logarithms, and I didn't get into that in this review lesson, but right before I introduce logarithms and have to do calculus with log functions, I'll have a special section going over that topic and reviewing that topic. Now, let's try to show or prove a trig identity, such as you have 1 plus tangent theta divided by 1 plus cotangent theta. And we're supposed to show that that whole ratio is equal to tangent of theta. So quantity 1 plus tangent divided by quantity 1 plus cotangent equals tangent theta. And for questions like this, the best thing to do is to try to, first of all, start with the left-hand side. So we're going to start simplifying the left-hand side, and then eventually show that you're going to get the right-hand side, in this case, tangent theta. And another tip you might use is to convert everything into sines and cosines, especially if you don't see any other, easy to spot identities right away. So if we simplify this and write the left-hand side in terms of sines and cosines, we will have again, tangent is sine over cosine, and cotangent is cosine over sine. And let's simplify those. Now you need to add 1 to a fraction, so we need to get common denominators. So you may want to write that as cosine over cosine plus sine over cosine. And the other one is sine over sine for the denominator plus cosine over sine. And now we can get common denominators, or rather, now that we have common denominators, we can add our fractions. So at the top you have cosine plus sine over cosine. And at the bottom you have sine plus cosine divided by sine. And since you're dividing two fractions, you write the top one, multiply the other one, multiply the reciprocal of the bottom with the top, and you might see where that's going to lead us here. So do you see a possible cancellation here? So these can be canceled, right? Sine plus cosine from the top with sine plus cosine from the bottom, since we're multiplying those fractions right now. And we're left with sine theta over cosine theta. And that is exactly what we're trying to get, right? Which was tangent theta. So we started with the left-hand side, simplify everything, and from there we got the right-hand side. And I'm going to leave you with one for you guys to do. Please work on this one, tangent plus cotangent in your numerator. So quantity tangent plus cotangent divided by quantity secant times cosecant show that that entire ratio is equal to 1. And if you have any questions about that, please bring it up on our course discussions board, ask me in class, or feel free to post a solution if you were able to get the proof of this one. So I hope that this lesson gave you some ideas about, some refreshers about trigonometry, and I hope you will take the time to memorize those basic identities and basic trig values at special angles, because like I said earlier, we're going to be using throughout the semester, and you're going to be glad you did that early on.